on how to use probability trees is now we're going to talk about what if we have like a more random question that you want to answer without doing out all the math, and you want to use my previous technique that I showed you for the easy dihybrid cross. So we have a dihybrid cross again. It's the same exact cross. You have two heterozygous for both genes, right? And so now we're looking at what is the probability that you get an offspring that is homozygous dominant for the straight hair, or for the curly hair, and then heterozygous, E plus EB, for the brown eyes. So they're heterozygous brown eyed. Well, so we know that the probability, right, when you cross H plus HS with H plus HS, the probability of this, so we can actually write this in probability H plus, right, is, this is a 0.5 chance, this is a 0.5 chance, equals 0.5 times 0.5, which equals 0.25, right? So you know that 1/4 of the offspring in the hair part of this cross is going to be H plus, H plus. Now we're going to do the same thing for E plus EB, right? So we want to know when we cross E plus EB, crossed with E plus EB, what is the probability that you get a heterozygate, E plus EB, like their parents? So we know that when you do out that Punnett square, right, you're going to get two of those squares that'll be heterozygous, right? So it's going to be like this square and this square are going to be heterozygous. So you have a 1/2 probability, or you have like, it's essentially like, the way you would do this out mathematically is 0.5 times 0.5 plus 0.5 times 0.5. So this would be 0.25 plus 0.25, which equals 0.5. That's the longhand way of doing it. So you know that you're going to get 1/2 of the individuals that are going to be E plus EB, right? So you can always do out, so then, you know, you essentially just multiply this, and then like you have E plus EB, which is 1/2, and you'll get like 1/8 of the individuals will be H plus, H plus, E plus, EB. And you could even do this, like you could make another one and go like 1/4 of these are going to be E plus, E plus. 1/4 are going to be EB, EB. So then you would get the whole tree where you're like 1/4 times 1/4 is going to be equals 1/16 will be H plus, E plus, E plus. You can do all of these things, or you can do 1/4 times 1/4 will be H plus equals 1/16, which will be H plus, ES, ES. Okay, so that's a lot of math on one board. Let me bring it closer to you so you can just see all my crazy mathematics here. But the idea is you can use these probability trees for all sorts of things. So figure any sort of, if you ever need to quickly, without doing out the whole Punnett square and counting, like figure out how many individuals in a dihybrid cross are going to be heterozygous for both traits. You could do that very easily just by doing this doing the multiplication tree. And then if you're going to do the phenotype, you can do the same thing. So you can figure out, you know, 3/4 of these are going to be, of these individuals will be dominant, and dominant trait, another 3/4, so you know that dominant for both traits will be 9/16. So anyway, that is my fast and easy way of doing this, and I will post up a longer description of how the dihybrid cross works and why you get all these ratios from Mendelian genetics at a later date. But I thought I'd put these up right now really fast so that you guys would have the extra material.